Hello and welcome to TN Academy. Today we're given a question about, we have W grams of bags of rice that are packaged in a factory and can be modeled by a normal distribution with a mean of 204 grams and a standard deviation of 5 grams. So, starting with the first question, we're just asked, for a randomly selected bag, what is the probability that it will weigh more than 210 grams? Now, to find this, we can do it by finding the z-score, for 210 grams, which would be our x value. And the way we find our z-score and its corresponding probability is as the following. So z is equal to x minus mu over sigma, where x is the weight that we're searching for, 210, mu is the mean, and sigma is the standard deviation. So that is 4. Where sigma is 5 grams. So, if we plug all that into our z equation, when we get 210 minus 204 divided by 5, which just simplifies to 6 over 5, which is 1.2. And then if we look into our normal probability distribution table, we can find the probability corresponding to z or z. And and that's how we do it. We look in our z-score table, and you find that the probability is 0.1151, or, this is 11.5%. Okay? So that is our answer to question 1. Yeah. We might need that z value. So we will just leave that there. So now for question 2, we are asked to find the probability that a randomly selected bag of rice weighs less than W grams. Oh yeah, where according to the model, 80% of the bag weighs between W grams and 210 grams. So, just a moment. Okay, so to answer this question, given that we know that, 80% of the bag of rice weighs between W and 210, we can say for B, the probability that something is between W and 210 is 80%. As well, we know that the probability above in question A of grabbing a bag that weighs more than 210 grams, that is what that probability is. That a bag weighs more than 210 grams is 0.1151. So, there's the only remainder is the whole of the bag. So, which is meaning to say that if you reach in the bag, there's a 100% chance you will grab some mass of rice, but there's no specific, without a specific signifier quantity. But what I'm trying to say is that then the probability that z will actually, that something will be less than our desired value would then be equal to 1 minus, I'm going to call this star, I'll just write it, 1 minus p wz 210 greater than, say that too. So this is how we could find the remaining probability that we're searching for, by removing, the weights between W and 210 and the weights greater than 210, because the only remaining weights would be those less than W. And when we substitute our values into the equation, we find that our answer is 0.0849. And that is the answer to question B. Now for question C, we are asked to find the value of W. And the way we do this is by using the inverse normal function. First off, though, so we know that 80% of the bag weighs between W and 210 grams. That means that 10% of the bag weighs less than W grams, and the remaining 20% is above 210 grams. Using the probabilities of the normal distribution, we can find the corresponding value to the 10th percentile score, since that's what we are looking for. And then we can use that, write out that z-score and find the value for W. So the corresponding z-score is negative 1.28, and we do take the negative as we are looking for the left tail in our distribution. Continuing on, we know that z is equal to our x value minus mu over sigma, where in this case the value that we're searching for is W. So we could just say whatever, just write in W for the x, because that again is the value we're searching for. So then when we substitute our values into this equation, we get negative 1.28 is equal to W minus 204 divided by 5. Okay, and then of course we rearrange our equation by multiplying both sides by 5 and adding 204 to both sides to find that W is just equal to 197.6. And that's the answer to question C. So the key to solving question D is, so we're asked the probability that exactly one bag weighs less than W. And we can recognize that this is a binomial distribution problem, whereby P of x is equal to n x, where x is the probability that we're looking for, and n is our sample size, I believe. N minus x, let's see. Yeah, where n, sample size, number of trials, X is the number of times for the outcome. And N and X, this is the number, this is our combination. And P is the probability of success for one trial. And the Q is the probability of P success, P failure. The probability of failure for one trial. Okay. So, since we know the probability of a bag weighing less than W, we already know that it is 0.0849. Just a moment. Wait. Hey guys, okay, just coming back. There might have been a bit of an error there, but we're looking at the probability of a bag weighing less than W, where we know to find W, we have to find the z-score that corresponds to W. Kind of going backwards here, but hey, so we do 197.6 minus 204 divided by 5, which gives us the 1.28, which I believe we previously had. But either way, the probability is approximately 0.8997. Pretty crazy. So then, to find the probability of one bag, exactly one bag weighing less, we're finding the probability of exactly one bag for the 10 bags. And the probability of success is what we just found, 97, times and it's multiplied by the probability of failure, which is simply the whole minus our probability of success. And I am just going to verify our equation. And we could see that it's raised to the power of x and n minus x. So that means this is raised to the power of 1. That's our probability of success. And the probability of failure is raised to the power of 10 minus 1, which is 9. And so when we put all this into our calculator using the combination function for our combination, we see that the probability comes out to be about 0.3877. So the probability that exactly one bag weighs, out of the 10 bags, weighs less than W is approximately 0.3877 or 38%. And that's all for the questions.